Hey guys, we are in chapter 10, section 4, solve trigonometric equations. Let's do a little warm-up to remind ourselves of a few things we're going to need for today's lesson. With this equation, we're trying to solve it, which means we need to find out what x equals. When you have a nice, neat little binomial on the left that's squared, you can actually take the square root of both sides, which means we have x plus 3 equals plus or minus square root of 5. Subtract 3 from both sides, we have 3 plus or minus the square root of 5, and that's our solution. This next one, a little bit different. I'm going to subtract 8x from both sides, and now solve it by factoring. So I'd have x minus 4 equals 0. X equals 4 and x equals 4 are our two solutions, which we only have to write once. Here I'm on the top of page 635, 10.4. I didn't copy this into your video, but it says you have verified trigonometric identities. In this lesson, you will solve trigonometric equations. Solve trigonometric equations. To see the difference, consider the following. We have sine squared x plus cosine squared x equals 1. That's one kind of equation. And then we have sine x equals 1, another equation. Equation 1 is an identity because it is true for all real values of x. In equation 2, it's only true for some values of x. When you find these values, you are solving the equation. So let's look at example 1. Solve a trigonometric equation. I have this equation here. And just like with algebra, you try to isolate the x. So the x is over here, and it's part of the equation. So I'm going to add square root of 3 to both sides. Cancels out there. I have 2 sine x equals the square root of 3. Now I'm going to divide both sides by 2. I have sine x equals square root of 3 over 2. So one solution of sine x equals square root of 3 over 2 in the unit circle there's my my angle. I've got sine is opposite over hypotenuse. So what angle gives me that? Well, I'm really doing sine to the negative 1 of square root of 3 over 2, which you can do in your calculator also. That gives me pi over 3, which equals 60 degrees. And that's a 30, 60, 90 triangle, which you guys should have memorized. So that's in that quadrant. But we do have other answers. I mean, I can get square root of 3 over 2 over here also, because the square root of 3 is positive at that point. And that measurement goes from here to there, so it's really 180 minus 60. Sorry, not 180 minus 60 is 120 degrees. So that's 120 degrees. So we're either at 60 degrees or at 120 degrees. It gives us the same measurement. And I can also say, sorry, we'll write it down, square root 3 over 2 is 2 pi over 3, which is 120 degrees. And honestly, since this sine x is periodic, you know, we go like this, back and forth and back and forth, I've got this line here that is y equals the square root of 3 over 2. So my answer is really going to be every time the periodic graph crosses the line y equals square root of 3 over 2. So my answer is quite interesting. I can get, oops, I'm still in highlighter mode, sorry. X equals pi over 3 plus any integer of 2 pi, or x is 2 pi over 3 plus any integer of 2 pi. Okay, that's the cyclical part of it. So we can say that this one is pi over 3, this is 2 pi over 3, and if I add 2 pi, I'm right here. If I add 2 pi, I'm right here. Repeat as necessary. Cool, I was hoping I included this graph. So this is the graph that the book drew. Because it's periodic, there'll be infinitely many solutions. You can use the two solutions found above to write the general solution, which is the infinitely many solutions. We've got this one, which is, well, let's do this. This one, which is in red, it repeats. And this one, which is blue, okay, and it repeats infinitely many times. Now with example 2, we're on an interval. So with example 1, we had infinitely many solutions. With example 2, we need to keep it between 0 and 2 pi, which is our unit circle. So same deal when we solve. I'm going to isolate the x, oops, the x best I can, equal, oh goodness. So let's subtract 2 from both sides, equals 9 tan squared x. Divide both sides by 9. I get tan squared x equals 1/9. Yep, I can take the square root of both sides. It's sort of cool. I get tan x equals 1/3 plus or minus 1/3. So using my handy dandy calculator, I can do tan to the negative 1 of 1/3, and I get 0.322. And I can do tan negative 1 of negative 1/3, and I get negative 0.322. So my general solution, x is approximately, because I did round, 0.322, and I can, well, we don't want to go a whole n pi. If you remember, my interval was between 0 and 2 pi. So I need to make sure my answer is only between those two spaces. So my first one of x is approximately 0.322 is the smallest one I'm going to get. The negative one doesn't work. So 0.322 is over in the first quadrant somewhere. If I add pi, that gets me actually 3.426 approximately, 464. So I'm over there somewhere. Okay, I can't go any further, but let's also look at x was approximately negative 0.322. That's going to be down here. If I add pi, I get x is approximately 2.820. If I add another pi, I get 5.961. So really I have 4 solutions, so let me list them out in black. I get x is approximately 322. I add pi. I get 3.464. I can't list the negative one because it's not in my range, but I get 2.820, and finally 5.961. 2 pi is approximately 6.28. So I need to be in between 0 and that. Cool? Alright, solve a real-life trig equation. The water depth D for the Bay of Fundy can be modeled by D equals 35 minus 28 cosine pi over 6.2 t, where D is measured in feet and T is the time in hours. If T equals 0 represents midnight, at what times is the water depth 7 feet? So we're looking for 7 feet. I'm going to grab this equation and take it to the next page. I have D equals 35 minus 28 cosine pi over 6.2 t. And I actually am going to make D equals 7 to start solving. So I'm actually going to move 28 cosine pi over 6.2 t over here. And I get 28 cosine pi over 6.2 t equals, I'm going to go ahead and get a little messy and subtract 7 from both sides. 35 minus 7 is 28. If I divide both sides by 28, it's magic. I get cosine pi over 6.2 t equals 1. Pretty cool. Now, cosine of theta equals 1. I can say this. Let's change colors. Cosine of theta equals 1. 1 is right there. When theta equals 2 pi, or when theta equals 0. So I can go ahead and solve that. I'm going to say 2 pi though. Pi over 6.2 t equals 2 pi. And that's 2 pi, 4 pi, 6 pi, etc. So remember, we have to take into account the infinite numbers of 2 pi. So solve this and multiply both sides by 6.2 and divide both sides by pi. So those cancel. I get t equals 12.4 n. That's my time, right? 12.4 n. So we said between 0 and midnight. So 12.4 is my only answer because If I doubled that, I'm past midnight. So that right there is my only answer. I don't need the n anymore. All right, let's practice. Find the general solution for the equation given here. Subtract 4 from both sides. 2 sine x equals 1. Divide both sides by 2. Sine x equals 1/2. If I take the inverse sine of that, I get 30. Now remember, I've got my sine function, and I can graph 1/2. So I've got lots of answers, right? Sorry, it's easier for me to do my infinite numbers when I'm in radians. So pi over 6 is my first answer. My second answer is going to be 5 pi over 6. And I can add the 2n pi to that. So we've got our one answer plus 2 pi plus 2 pi, and another answer plus 2 pi plus 2 pi. So there are general solutions. Okay, let's try this one. Okay, we need answers just in the interval here. So cosecant squared x equals 4/3. Square root of both sides. Cosecant x equals 2 over the square root of 3 plus and minus. Okay, so this gives me 1 over sine, or I can say sine x equals plus or minus square root 3 over 2. So we have two types of answers. I'm going to do square root 3 over 2 and negative square root 3 over 2. So here we are. I've got a positive 60 degrees, which is, I think, pi over 3. Yep. And negative pi over 3. So I've got pi over 3 and negative pi over 3. So for pi over 3, I've got this one, and then, nope. Sorry. I know I've got positive here also. So this is pi over 3, and over here I have 2 pi over 3. So that's 60 degrees and 120 degrees. Again, down here I have negative pi over 3. And to get over here, I need to add four pi over 3. That's this one right here, 4 pi over 3. I can't use the negative one, but I can use this one. So that would be 180 plus 90 is 270, plus 30 will get us over here. So that's actually 300 degrees. And that changes into radians, 5 pi over 3. So I have 4 different solutions, all within my unit circle. It's a little hard to do, I know. All right, example 4. What is the general solution of this one? So write the original equation. That's a cubed, which is really crazy. Sine cubed x minus 4 sine x equals 0. Weird enough, I can actually factor out a sine x. I'm left with sine squared x minus 4. This is a perfect square trinomial. right? So I can factor that out. Sine x plus 2, sine x minus 2. And I can set each one equal to 0. Sine x equals 0, sine x equals -2, and sine x equals 2. If I take the inverse of each one of those to find my angle, I know that my angle is going to be, for this one, equals 0 and pi. For this next one, let's see, 2 negative inverse sine. I can't actually do anything with either one of these. So with the interval, those are my only answers. So my general solution is going to be 2n pi and x plus 2n pi, where n is any integer, which gives me d. All right, you see that? Yeah, we can do it. Amazingly enough, an equation can be in a quadratic form, so we can use a quadratic formula. I know it's weird, but here I have cosine squared x minus 5 cosine x plus 2. So we really have ax squared plus bx plus c, and I can use the quadratic formula for it. The only difference here is I don't set it equal to x anymore, I set it equal to cosine x. So I have negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, do the math here. I get cosine x equals 5 plus or minus the square root of 17 over 2. So that is about 4.56 or 0.44. So use your calculator and take the inverse. Cosine -1 of 4.56 equals no solution. And then cosine -1 of 0.44 gives me about 1.12. And in between the interval of 0 and pi, that's my only possible solution. So not too awful, is it? Extraneous solutions, okay? When solving a trig equation, it is possible to obtain extraneous solutions. So you should always check your solutions in the original equation. Okay, plug it back in and see what happens, because it might not work. Let's try this one, and there will probably be an extraneous solution. Let's see, 1 plus cosine x equals sine x. Okay, we're solving this. I don't know what to do, but I do know that if I have a cosine squared and a sine squared, I can use the Pythagorean identity. Let's go see what happens there. I know it's crazy. So that first one, if I square it, I get 1 plus 2 cosine x plus cosine squared x equals sine squared x. With that sine squared x, I can actually substitute 1 minus cosine squared x. That's the Pythagorean identity. And now I'm actually going to add cosine squared x to both sides and subtract 1 from both sides. So I get 2 cosine x plus 2 cosine squared x equals 0. Factor a common factor out of there. 1 plus cosine squared x. That changes. Oh, so I've got my two zeros. I can set this equal to 0 and that equal to 0. So I get 2 cosine x equals 0. So cosine x equals 0. And if I do the inverse of cosine 0, I get x equals pi over 2, which is well in that range. So I can also do 3 pi over 2. And then the other one I have, hold on, let me move that. 1 plus cosine squared x equals 0. Cosine squared x equals negative 1. Ooh. Yeah. I can't take the... Actually, I see my mistake. Did you guys see my mistake? I'm going to leave it there and we can learn from it. Here, I took out a cosine x, but I forgot to actually take the whole thing out. So I'm going to erase that 2. Now I can actually solve for it. So I have 1 plus cosine x equals 0. Subtract 1 from both sides. Inverse cosine of negative 1 is 180. I can't, which is pi. I can't do 2 pi because it's less than, it's not equal to. So I have these two solutions and this solution, but I really should check them. My original equation is 1 plus cosine x equals sine x. If we check pi over 2, I get 1 plus cosine pi over 2 equals sine pi over 2. 1 plus 0 equals 1. 1 equals 1. We're good. If I check pi, 1 plus cosine pi equals sine pi. 1 plus a negative 1, if I type that in, equals 0. 0 equals 0. We're good. And then try that last one, which is 3 pi over 2. 1 plus cosine 3 pi over 2 equals sine 3 pi over 2. 1 plus 0 equals negative 1. 1 does not, in fact, equal negative 1. So that one doesn't work. That says nope. Alright, general solution. I can factor sine x. Sine x equals 0. Sine squared x minus 1 equals 0. For this one, x equals 0. And it's a general solution, so it's going to be 0 plus n pi will work. And then sine squared x equals 1. Sine x equals plus or minus 1. And that's going to work at 90 and negative 90. So that would be a pi over 2 plus n pi. Okay, we don't actually have to worry about that one because the pi over 2 plus n pi covers everything. So those would be my solutions. I think we square both sides. I get 1 plus 2, nope, 1 minus 2 cosine x plus cosine squared x equals 3 sine squared x. The right side goes 1 minus cosine squared x, 3 minus 3 cosine squared x. Alright, I'm going to subtract 3 from both sides and get a negative 2 over there. And then add 3 cosine squared x. And that gives me minus 2 cosine x plus 4 cosine squared x equals 0. Let's rewrite that. 4 cosine squared x minus 2 cosine x minus 2 equals 0. I can actually factor a 2 out of everything. I get 2 cosine squared x minus cosine x minus 1 equals 0. I don't think I can do the a times c. Negative 2, so a times c is negative 2. I need two numbers that multiply to negative 2 and add to negative 1. Negative 2 times 1 is negative 2. Negative 2 plus 1 is in fact negative 1. Alright, so let's use these, and I need a new page. 2 cosine squared x minus cosine x minus 1 equals 0. Minus 2 cosine x plus cosine x minus 1. Factor by grouping. I can take out a 2 cosine x, and I get a cosine x minus 1, cosine x minus 1, cosine x minus 1 equals 0. Nope, I'm skipping steps, sorry. I've got 2 cosine x plus 1 left over. So cosine x equals 1 when x equals 0. And then cosine x plus 1, 2, gosh. When does cosine x equals negative 1/2? When x equals 120 degrees, which is 3 pi over 2, I think. That's this one right here, when that's 60. 2 pi over 3. So when x equals 0 and x equals 2 pi over 3 are our two answers there. It's a general solution, so we have to add 2n pi to this one and 2n pi to that one. Cool. Alright, we're solving on an interval. I just changed cosecant x to 1 over sine. I'm going to multiply both sides by sine x. That gives me 2 sine squared x equals 1. Sine squared x equals 1/2. Square to both sides. Sine x equals plus or minus 1 over the square root of 2. So here we have our answers. It's the same as pi over 4 and negative pi over 4. I have to be in that interval though. So pi over 4 is 45 degrees. So I can be both here and there. So this one is pi over 4. And then this one over here is 3 pi over 4. So those are my two answers. And last but not least, let's see, how am I going to solve this one? I think I want to factor out a tan squared x. I have 1 minus sine x left over. And I can do this. Tan x equals 0. Tan x equals plus or minus 0, which isn't a thing. 1 minus sine x equals 0. So sine x equals 1. So x is going to equal pi over 2. So here I'm between 0 and pi. There's pi over 2, there's pi, but it's equal to, so I can also do pi. And then tan x is 0. So my answers are 0 and I think I can do pi. Nope. So those are our answers. Cool, that's it. That was long. Nice work.